Hey everyone, thanks for stopping by. Have you ever had your Victron DC-DC charger get so damn hot that you think the cables are starting to melt? If so, stay tuned for this one. Okay, welcome to my VW Crafter. It's a 21 model and the Victron gear is in the back, so let's go. Okay, so we're underneath the bed at the moment. I've got water on this side, electrical and batteries on this side, so this is where the Victron gear is. Today's project is to try and cool down the Victron DC to DC 30 amp charger that's in the back of the van here. What I have tried to do is use the DC-DC charger to run the van motor to charge up the batteries for an hour or two to just top them up. And this problem came to a head last week when it was stinking hot and we weren't actually in the van much. So the van was closed up and I had the engine running for a couple of hours, came out and went, hello, something's not working here, and worked out that the DC-DC charger was basically going into fault every few seconds. It would charge, then cut out, charge, cut out, and give us basically no charge. So I touched the outside of the box and it was stinking hot. In the past, I attached a thermal switch to the solar because this is already pretty warm. It's probably about 25 degrees outside. So this little guy gets warm, and just on the side there is a mechanical temperature switch. So that works pretty well, and it has in the past turned on this old computer fan. I'm going to put a thermal switch on this part of the Orion, which is the big heat sink, a finned heat sink. So both of these will have thermal switches on them, going to a voltage regulator and fans, little blower fans. And I've made up a couple of 3D printed ducting pipes to focus the blower fans onto the underside of these fins here, so it'll force air up behind the units and hopefully keep it cool. This is the battery bay for all the battery cells in there. So I'll put another grill on the front here, and behind it I will have two, I think they're 80 mil computer fans, style fans, and they're pretty low amperage, so they don't spin very fast, but they will just push a little bit of air into this this cavity. Alrighty, to get the job done, there's a few things on the floor here that I'm going to run through to help us get it done. So obviously you're going to need the blower fans. I've got one blower fan each for each of the Victron units, and I'll leave a link in the description below on where I got those from. Pretty cheap. Then I made up some 3D printed ducts that will direct the flow of the air so it's not wasted onto the bottom of the fins. Alright, so that's them, a couple of screws to hold them onto the backing board that's in there. Some spade clips, electrical terminators, they'll be used for the thermal switches and whatever else. A couple of zip ties to tidy it up later, a little bit of heat shrink and a lighter, a drill and a small drill bit to help with getting the screws started on the signboard, which is what I'm using, and I've used a lot of signboard in the van. Wire strippers and crimpers, screwdriver, little wire cutters, assortment of wire. This is my thermal switch. This is rated at 50 degrees, normally open, and then when the temperature on that face gets to 50 degrees, the circuit closes and you have power going to the fan. So that'll just get screwed to the side of the heatsink on the Victron. I've got a voltage regulator. I also made up a little 3D printed shell for it, but these are off Amazon as well, and really cheap, but they'll take anything from 4 volts, 4.2 volts I think, all the way up to 40 volts, and that way I can regulate 12 volts perfectly coming out. To attach the ducts to the signboard backing, I'm going to use, I think, this foam conduit tape. It's rated to 90 degrees, so I think that might be a pretty good option. I didn't go to the effort of putting little screw tabs on here to then mount it, because I was going to use Velcro, but the problem with the Velcro is it lifts things off the surface quite a bit once you've got the 2 layers of Velcro. So I had this foam tape kicking around. I think it'll probably do the job pretty well. The motors I will screw to the signboard though, and then a pair of wire strippers. That's about it. Alright, let's get started. Alrighty, that's probably about the best angle I'm going to get. This has got the double-sided tape on it, and I've just got the motor sitting in there, which, oh, stuck on already. Okay, let's try that again. Okay, I've got to line him up and press. Now, I don't want to press too hard in the center of my 3D print, otherwise it might break. Okay, so that's on, and then this little motor just slips into the opening. Okay, drill incoming. One hole. And this is going to be a bit tricky. I think what I'll have to do is screw that in for starters, so it don't move. Okay, one in. That should get me started. Good. First duct on. Okay, next duct. Double-sided and sticky, and very sticky. Gotta line him up. About there. And this little fan is going to go in there. Done. I really like working with the signboard material. It's a composite. It's got an thin aluminium surface on the front and the back, with like a ABS material in the center core. You can bend it, you can easily cut it and snap it. It's great. Okay, so that's my 2 fans. So what I've done here is I've got a little wiring harness where I have 3 attachments, so one for each of the little blowers, and this one is for the existing computer fan, but I could also do another Y, black and red Y, off this one to drive further fans. So just a little bit of future proofing there. I'm actually going to have the thermal switches on the input side. That way I can have all the fans come on when one thermal switch is triggered, so rather than having individual thermal fans being triggered. So that's the way I've decided to go. I will have 2 thermal switches, but if either one of them gets triggered, all the fans will come on. So I'll show you a post-it note sketch of what I've got in mind for that. If they join, the circuit works. If that one joins, the circuit works. Okay, and that goes to the battery. Good. If anyone's wondering, here's the diagram. Something I forgot to mention was with these thermal switches, this face here is going to be touching whatever gets hot. Okay, in my case it's an aluminium heatsink, but you want that to be a good connection, a good contact. If it's not touching the whole surface, then it's not going to transfer the heat. So you have a couple of options. You can use thermal paste, which you might have seen in your computers, where circuit boards have their heat sinks connected with thermal paste. It's a silvery looking stuff, or these little thermal pads, which is what I'm going to use, and you just peel these off and stick them on. They're very flexy. You can see that it's super flexy and soft, and it's kind of malleable, but I'll just stick that on there, and then when that gets squashed onto the aluminium, it'll make a good thermal conductor. The other option is, if you can't find these, I think I got these on eBay 20 years ago, you can go down to JCar and buy yourself a square sheet of it and cut it to size. So that's probably the quickest option for most, is to go down to JCar and grab that. You're only going to need 1 centimetre by 1 centimetre square pretty much, to give it that little bit of connection. So then that'll get screwed to the aluminium. So that's where I'm at. So here you can see the 2 blowers and the ducting. On the right hand side I've got a square cut out into the backing board, which goes into the cavity of the van, and I'm going to do the same on the left hand side as well, so I can all breathe a little bit easier. Okay then, so that's it, it's done. It's not real pretty, but basically you've got the DC-DC charger, the solar MPPT, both with thermal switches on them up there, and that switch then triggers the input power from the battery, the house battery, going in. So this voltage regulator only has power when they get hot. That way you don't have an LED burning away the whole time. So it only becomes active when these thermal switches click in, and then both these blower fans fire up, and using the ducting direct the air behind the back of the units through the cooling fins, the heat sinks, and pushing the bulk of the air through the timber cavity that we've got as the walls to the skin of the van. So yeah, that's it. It's a bit fiddly in there, but I think it'll work pretty good. Okay, well, thanks for watching. It's been a little bit fiddly. I've had a lot of interruptions today. Probably could have done it in about 2-3 hours, but visitors and all that sort of thing. Anyway, thanks for watching if you got this far, and if you have any questions on this or anything else that I've made in the past, leave a comment below. Thanks, great.